part is all about surface area. Okay, so surface area, if I can get your screens down, that'd be great. Surface area. What's in that phrase, Maham, for surface area? Area of what? The surface, correct. So area of the surface. So for example, this particular glass, okay, the area of the surface. So the curved area, the curved surface, which is basically what kind of shape, Trish, is this kind of look like? Starts with letter C.
Circle. Wait, no.
Cylinder, correct. Okay, are the two surfaces at the top and bottom? Yes or no? That's a good one. Yeah, are they at the top and bottom? Lavia, do we have two? How many surfaces do we have for this glass? Two, correct. We've got this curved surface and we've got the surface at the bottom as well. Now, with this shape, it can get quite full on, right? Because we've got different parts. I'm going to show you how you can get through this really quickly at this pace. Boys, can you stop? Okay, Lockie, can you just sit over there? Okay, can you not? Elliot, can you put that away? Okay, cool. So here, guys, I'm going to show you how you can get through this question really fast. So I'm just going to, what can I do with this shape? What do we call this particular shape, Taylor?
A house.
Starts with a C. It's a type of shape. Yes?
Composite.
Composite. Meaning, what does that mean by composite, Lockie?
Made up of multiple.
Yeah, so a triangle and a rectangle.
Square.
Right.
Square.
So what you want to do is,
Okay.
you want to approach it like this.
Yes,
How many of these triangles are here? 2. Lavia, how many of these rectangles are here? Is this, what, good question. It does look like, a good statement, it looks like a square, but it's technically not a square. That's 5 meters, that's 2.9. What's so special about a square? Yeah, I know it does look like it visually, but square has all equal sides, right? So then, I'm going to add this shape, which is what? I'm going to call it the front, okay? And what dimension is that? That is 5 meters by 2.9 meters. Great. What about the triangle? What's the dimension for this triangle? 5 meters. And what's the height?
Wait.
How do we work out the height of this triangle? Tritania.
3.1.
Can we do something else other than Pythag?
Wait, 3.1?
That's okay. Yeah, 6. This height, take away this. So it's going to be 3.1. Now, we're going to multiply this by 2. Because why? We've got these two up there on that side. Now we're going to do the sides. Right? That kind of looks like a parallelogram. Okay? So now you've got here 4.
7 times 4.
And then you've got what else? 7.
Is that a parallel?
How many are there? How many are there? There's 2.
But that's a rectangle, right?
Then you've got, well, this side is parallel to that. And this side's parallel to that. Yeah, though it is a type of rectangle, yeah. So now we're going to do what else? What other actual side or surface do we need to include here, Romeo? We've done the triangle, the top. We've done the front of the actual house. Shh, Taylor. We've done the front of the house. We've done the side panels that are at the top. And we've multiplied it by 2. What other surfaces do we need to add?
The sides.
The side, yeah, correct. So I'm going to call this the side of the house, which is what? 7 by 2.9. Then what else do we have to add here, Maham? The bottom, correct. So I'm going to put that there. I'm going to call that the bottom. And what are the dimensions there? 5 by 7. So that's the best way to approach that question. There's too many things going on. Is there 2 of these?
No.
No. There's no 2 surfaces. Then what do we do here? What do you think the next step is going to be after that? After we now that we've drawn and put the dimensions in, Lockie, what can we put? How do we find the area of this?
You just put the formula in.
The formula, yep, which is half times base times height. And what are we going to do next? Multiply it by what?
By the length.
2.
2.
Why? Because there's 2 of those. Then we go through the next one, the front, which is this. Do we have our dimensions in there? Yes. What's the area of that? Length times width times that by 2. Same thing here. Length times width times up by 2. This one, length times width times up by 2. Same thing here, length times width times up by 2. This question is quite chaotic if you want to make it chaotic. This is how you structure it. What's the next step after formula, Lockie?
Substitute.
Substitute. Do we have our base and our height? Do we need to look at this anymore, Assad? Do we need to look at this? No. All we have to do is just look at the shapes that we've just written. So I highly suggest you do this. Approach these questions like this. So what's that? 0.5 times my base, which is 5, times by my height, which is 3.1, and then multiply that by 2. Next one, length times width, which is what? 5 times 2.9 times that by 2. Same thing here. Length times width, which is 7 times pi by 4 times up by 2. Same thing here. 7 times 2.9 times up by 2. Same thing here. 5 times 7. I don't times up by 2 because it's the only bottom side. Then, put that in your calculator. So, when you approach this question, you draw each shape. Okay? And you're draw each shape. Second thing is, put your dimensions in. It doesn't take that long to do that. When I was explaining it, it will take a while because I'm explaining it to you guys. But when you approach it, quickly draw these dimensions. Then, third step is formula. Fourth step is substitute. Fifth step is your answer. Okay? That's all you have to do, guys. Like you've done really well in your formative assessments. You've approached it in that way. You lost like barely any marks. The only marks that you did lose was just on that Pythag part. But on the measurement part of it, you've done really well. Because you've approached it in this way. If you have a strategy, you can do really well. So yeah, that part is done. That's surface area. I'm going to give you about 15 minutes to 20 minutes to have a go at that next part. 15 minutes, 20 minutes to have a go at surface area. Okay?